Good afternoon, everybody. My name is Nathan Ness. I'm a senior staff SE on the Kubernetes team at VMware. And today I'm going to talk about Git, or version control for infrastructure, right? So a lot of people use standardized tools like Terraform or Ansible, and if you want to track those changes, you would use something like GitHub or GitLab or some type of version control system. And so I'm just going to go over the introductory of basics and very common Git commands to use just to kind of version your infrastructure as code as you progress down this. So what is it? It's a distributed version control. It allows the coordination of work between different developers or different platform operators or infrastructure teams that can collaborate and commit and not step on each other's toes as far as what's happening within a single source control repository. You can revert back at any time, so if you make a change, it's obviously self-documenting by the bare nature of committing the code and creating these snapshots. And you can use either this on local or local and remote repositories. So you don't need an internet connection to use Git, you just need to install it. You can have all of your repos be completely local if you want. You don't have to push them out to a remote repository. Even though if you're collaborating with other folks on your team, then you would use a remote repository to push and make sure that you're not stepping on each other's toes and have that single source of truth stored in some remote location. So it keeps track of code. Like I said, we can create these snapshots in time at any point that you want by making a commit. And that will just basically take whatever's in that commit message and create that snapshot, which allows you to, again, then to revert back at any time, look at the changes that were made from an auditing perspective, and you can also stage the files prior to committing and show like a difference. So you can see what's attempted to be committed, what the changes are before you commit them to your head repository or working space. So kind of the benefits: you never lose your work. It's always tracked. You always get this great history. You get blamed for bugs, right? It's built into it. So you can see like who did what and why did the system go down or up, or impacting new features without impacting production with the use of branching, which we'll go over. And collaboration, right? The ability to work as a team into like a single repository or a single branch and have all of that being tracked. And again, without the stepping on each other's toes is huge, right? If you guys are doing duplicating work and try to push that to a remote repository, you're going to see a conflict there, and you can resolve that conflict on all right, who's right, and merge that in safely. For the managers, you get documentation, right? I mean, everyone, I think, requires this, even though it's probably the last thing that's talked about or even discussed. It's never documented properly. Version control is documentation by nature. So I'm a huge fan of things like Terraform and CI/CD and driving infrastructure through code because you can tell the exact way that the underlying system was provisioned and was installed. Because that file, whatever it is, whether it's a Terraform file or whether it's a parameters file in a CI/CD pipeline, that's exactly how the end system was provisioned. And so you kind of have that single source of truth as long as you remain on that track and don't do any like out-of-band changes. Right? So unless you're doing something out of band, you're always going to have that documented system, right? So for new team members, maybe someone left, they can actually just go back to the repo and see exactly how everything has been provisioned. They may have to get used to a new tool set, but at least within that tool set, everything is documented. Progress tracking, so you can see who's doing what and when. Obviously, with every commit, you can kind of see a graph. GitHub graphs it for you around how much you're committing, the number of commits that you're making a day, and kind of gives you this nice progress around what's being done. It's super easy to get started with it. Like I said, you don't even have to have a GitHub or a GitLab account. You can do everything locally if you want. It's not very common. But on a Mac, you can just say brew install git, Ubuntu, apt-get, Red Hat, CentOS, or Yum. And then on a Windows box, you SSH into Linux or a Mac, and then do what's above. I'm just kidding. Obviously, Windows supports Git as well. So let's kind of talk through the workflows of Git. And again, I'm going to talk about 1% of Git, but it's absolutely the most common commands that I use personally in my lab environment and with customers as well. So on a local computer, when you actually create a repository, this is actually what's being created kind of under the covers. So you don't necessarily see these folders minus the working directory. And so then also when you create or when you want to push into a remote repo, then you can actually create the remote repository as well or sync with what's on your local computer. But essentially there's these three spaces. The working directory is what you're changing code in as well. There's an index that acts as just that. It's just a staging environment, and we'll get through what commands actually add into the staging environment. And then head is where your last commit is stored, right? Like I said, the only thing that you're probably going to interact with, you don't really see index, you don't really see head. You're just going to interact with the working directory in the workspace typically. Okay. So to check out one, most of you, if you've used Git in the past, you've probably done this and like cloned a repo, right? So I can say git clone, which is going to basically grab the remote repository and then clone it into your working space. So that allows you to work on it locally on your laptop. And then also if you own that repository remotely, you can also work on it locally and then push back up into the remote repo to push all your changes. So to create a local repository, if I want to create this local repo, I can just say git init. And in this particular case, I'm creating a repository called network profiles. And this will create that directory structure. So if you look at that saying git init, this is on my local laptop here. It's actually going to create a directory called network profile and initialize that repo with those three spaces, okay? So as we're adding files to the network profiles repo, when you start adding files, they go into basically what's called an untracked state, meaning you're not tracking them in underneath version control. You actually have to add the files to Git in order for Git to track them, okay? So after they've been added, then you can do your commit and you can attach a message to it like, hey, this is the change I'm doing, some very small message that says changing network profiles, adding a load balancer, so on and so forth. Whatever type of code that you're tracking, just put in a simple change message to kind of go through like an audit around, maybe it's tied to a particular change request in your CMDB. You could add that into the commit message as well. And then obviously, if we do want to push that remotely, we can push it to the remote repository, right? So it's as simple as that. Is when I do a git add, it adds it into index. When I do a git commit, that puts it into head, right? And then when I do a git push, it's going to push those local changes to that remote repo. And you repeat that workflow over and over. So the kind of the goal here is to make a lot of smaller commits, not necessarily do a whole bunch of changes and then do one massive commit, because it's going to be really hard to try and, let's say you're testing something and it's not working. So you'll want to test something, commit it, try the code out. If it works, great. If it doesn't, then you can repeat this process again, right? But the goal is not to make a whole bunch of changes and then make this massive commit into the repo. It's certainly allowed. You can make these snapshots whenever you want, but the more snapshots you have, the easier it is to roll back to a known good state. And we can talk about branching here in a second to even be more safe in this regard. So when we add files, right, we create these files, and here I'm creating a README file, right? It's just going to be basic documentation for the repo. Basically, every repository has a readme.md, which explains the repository's purpose. But when I create the file and say git status, you can see that README is not being tracked. So I actually do have to add it into a track state for Git, and it's a simple git add command. So I can git add particular files and cherry pick them, or I can say git add dot, and that will add every file in that directory to be tracked. And now you can see that I can say git status again, and you can see that I have a new file that's going to be tracked underneath my Git repository. And that's going to add it to the index, so kind of that middle layer there. Okay. So now that it's in index, I need to commit it, and again, that committing it is going to make that particular snapshot with a message, right? So again, we can just say git commit, add a message, which is saying, hey, I added a README file, all right? Which will then push those changes and make that snapshot in time and put them into head, all right? Creating the remote repository, there's several ways to do this. I can either do it via the CLI, via like a curl command, which is using GitHub's API, or I can just go more simply and go to github.com, log in, and say I want a new repository, and you can initialize it with whatever you want. I should note, like, there's some files that you don't want to be tracked, right? So there's some, like for instance, if you use Terraform in your environment, you don't want to track TF state. It's typically not a file that is tracked, or TF state backup. So GitHub allows you to create what's called a git ignore file inside your repo, and it will always ignore that type of file. So I don't have to cherry pick. So I can say git add dot, which is going to add all of them, but it will ignore the ones that you've specified in your git ignore file. And there's many examples of this around, like, hey, maybe there's a secrets file or a passwords file that I don't want to add as well. You could add that into your git ignore file. Obviously, you don't want any type of passwords going into version control. And there's other methods of abstracting those as well, right? You can use things like Vault from HashiCorp as well to say, like, just because it's inside the version control, it's just pointing to a secret in Vault, right? So when we push it, obviously it's going to push that to the remote repo. And again, just because I added this to locally, when I initialized this locally, not from GitHub, I actually need to set the origin. And so when I created a repo or initialized the repo, everything is going to be tracked as on the master branch, it's called. And it's the default branch when you create every repo. It's the only branch unless you branch out, which we can talk about here shortly. Okay. But once I have that, I can push, and it will push all of my files that are currently in head to master. Okay. And it'll sync that up. So now I have a sync between what's locally in my working directory and in head to my remote repo. So what if I have this production system that's using the master branch? I have this tree that's going along, and all of those little blue dots are commits, and that's running fine. But now let's say I want to add a new feature. Right, so maybe I want to add a different load balancing feature to network profiles, or I want to add some more code to a Terraform template. I can actually create a branch and not disrupt master. Because if people are actively using master for their workflow and I'm trying to do something new, I can actually just create a new branch, which is going to take the snapshot of wherever I choose, and then I can start working on the new feature without disrupting what's actually running in master, right? So all they are is pointers to whatever commit that you branch off of, which allows me to work independently of what's happening inside the master branch. To do this, you can say git checkout, -b, whatever branch that you want to create there. And then when you say git branch, you can see what branches are available to you. To go back to master, you can say git checkout master, right? And so that will put your working directory into that particular branch, right? And then I can actually set my pushes to load balancer test instead of master. So now when I'm making commits and adding additional features or additional files, now I'm actually going to push into the load balancer test branch. Okay. So when I do a git pull, I can update and merge from my remote repository. Let's say other team members have been doing work inside that repo, and I want to catch up to what they're doing so I don't step on their toes as well. So I can actually do a get pull, and it'll actually pull all the changes remotely and update my last commit and my working directory to all the changes that have been taking place, right? And so it will show you which files have been changed. You can actually do a command that says what is actually changed in the files, but it'll kind of show you, just give you a little graphical layout of what files have been added, changes to those particular files, and then it'll actually create those files in your working directory and update your head as far as the commit. So this is actually going to pull and fetch down all the remote changes and put it into your working directory. So get fetch is used again to fetch the changes, but it doesn't actually merge them into head. It's just going to fetch them, and then you can also merge them as well. It's not very common to use that. Most of the time I just use get pull to catch up what's happening remotely. And then I can set my local changes up and start creating and adding additional changes as well. So adding code to the different branch, we talked about it a little bit, but again, I can start adding different files. There's a pretty cool Git extension. So as you see, like as I'm changing and modifying files, my command line actually prompts change. So you can see, like when I created the load balancer test directory, I have load balancer test, everything's green, so that means I'm caught up with master. But then when I start adding files, like I added a JSON for a small load balancer. So then I see that I actually have changes that need to be added and committed. So now when I created that file, I added it in. So that's great that I added it, but now it's just waiting for me to commit it. And so when I commit the file, I just say I'm adding a small load balancer profile to the repository. Then that commit message aligns me with head, which actually puts my prompt back to everything's good again, right? So it gives me a very nice local, quick reference of where I'm at within the repo, whether I'm caught up or whether I need to add something, or whether I need to commit something. Okay, and then I can push it into the remote repo, or set my origin to that branch of load balancer test, and then push it in there, which will push the small load balancer JSON file into the load balancer test branch. So let's say now I want to merge that, right? All the changes were good. I can say, hey, this load balancer test branch worked out fine, and now I want to merge that back into master. And it's as simple as get merge load balancer test, and that will merge this branch into master. The load balancer test branch will not go away. It'll remain there. You can always go back to it. You can always switch branches to continue, adding features to that, and then merging them back in as well. So here I have the master branch. I checked it out, but then when I do the get merge, then it's going to basically align those commit messages. And when it does this, it's actually going to look for conflict. So if there's conflicts in my master branch that are conflicting with what I'm trying to merge, it's going to show you that and say, like, hey, there's an error, and this is where you need to look, because this is a conflict between the master, which is great, right? Because now I can see, like, if I'm going to step on someone's toes, who's right, who's wrong. You can talk through that and collaborate around, like, hey, should we merge this, or should we just merge part of it? Again, very simple workflows, but allows just the complete tracking and history of work being done. So replacing local changes, everyone makes mistakes locally. So sometimes you got to pull from what's in the remote repo. And you can do this locally by get checkout file name. So if I screwed up my load balancer, small load balancer profile, I could say get checkout that JSON file, and that will replace what's in head back into my working directory space, which is fantastic. So kind of reverting back work. Yes?
So you take a similar approach that, let's suppose you haven't done work in a long time.
Yeah. Yeah, you can. So typically what you would do in that regard is you would do a get pull. which will pull down all of the changes, typically in the remote repository, right? Or if you haven't done any work locally yet, then you could do a git clone and clone that entire repo down. But if you already have it locally and you want to catch up on all changes that have been committed, then you would typically do a git pull. Okay. Yep. So replacing local changes from a remote repository. Let's say you really screwed up your local workspace and you actually have to pull from the remote repo. You can actually pull remotely with the get fetch origin, and then you can reset your working directory with what's in master or whatever branch you're using, right? If it was origin, load balancer test, then you could replace those local changes. If it's just on the master branch, you could replace those changes and pull down what's locally if you've screwed up everything locally. So this is probably the picture slide here because it kind of illustrates the entire Git workflow. But again, creating a repository creates these working spaces. Doing a git add adds the local files to be in a tracked state and puts them in a staging area. Doing a git commit is going to add them into head and create this snapshot in time around what is in that particular commit. You tie a message to it, giving it a simple name of like a change log. If I want to push, I'm going to push it into a remote repository with a git push. And then again, if I'm doing a git pull, I can sync down my remote changes to update my latest commit and my working space or my working directory. And then finally, a git clone. If I want to pull down the entire repo and I don't have it locally, will update everything, right? And so these are the very common commands. Yes?
At what point would a file stay in the staging, not be committed? Every time I've looked at Git, there's always a Git add, immediately followed by Git commit.
Yeah, totally. Oh, sorry. Yeah. So the question was, when would the file stay in staging? Why would you just do a git add and never do a git commit? And that's typically never. Like it's always that way. Like a lot of times, if they're not in a tracked state, I need to add them and then commit. I don't have to add them again. Once they're tracked, they're tracked. So it's only kind of a one-time thing that they need to be added. Because after that, then you can just do commits, add a message, and done. So they're very rarely long-lived in index because at some point you are going to want to make a commit and utilize version control to that. It's not clicking save. I would say like it's to track it. It's to start tracking that file underneath it. So I would say the save is more on the commit message where, yeah, the commit is actually the save and the snapshot in time. And there's some files, like if I have a lot of files in my working directory, I might not want to add all of them into my index. So that's the purpose of add in the beginning, unless I want to add all of those files into a .git ignore file, which is probably not the case, right? So any other, yes, sorry.
So what happens if you have an entire folder structure? You start by adding it all at one point.
Mm-hmm.
You're doing a bunch of work and you decide, no, I want to move files and move it around and so on and so forth.
Mm-hmm.
How do you deal with that? Is there a way to be able to say, just get caught up with all the changes that are made?
Yeah. Yeah, if like initially when you start off and maybe you already have a huge file subset folder system that you want, you can dump all those in there. And typically I git add however many I want, maybe it's all of them, and do a git commit, and it's just I put my commit message as initial commit, just to get the file structure up there. But if you do change it, and if you do make a lot of changes without committing, then your git commit message is going to be really large. Like if you're moving files around and changing a bunch of different things, all of those are not going to be in a commit message unless you do commits as you're kind of going through.
Well, my question was more about, is Git smart enough to realize that the file
Yes. Yes, it is. Yep.